So theorem, if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points. First I will draw a triangle. Okay, so triangle. Okay, say this is triangle ABC I am taking. They are telling if a line is drawn parallel to one side of a triangle. I have taken triangle as ABC. They are telling a line is drawn parallel to one side of a triangle. That means you take any one side. We have three sides, this and this. I will consider this side BC, this side. Okay. A line is drawn parallel to one side. So we have to draw one line that is parallel to this side BC. This, so I have taken this line. So now this line is parallel to this. That's what they're telling. If a line is drawn, this line parallel to one side of a triangle. This is parallel to this triangle. So next, continuing, to intersect other two sides in distinct points. That means when you draw this parallel line, okay, this is parallel to this side. Okay, remaining sides are what? This and this. That means AC and AB. Just 1 minute. Yeah. Okay. They're continuing to intersect other two sides in distinct points. Other two sides of this triangle ABC are what? AB, this one, and AC. AC. These are the other two sides. To intersect other two sides in distinct points. That means when you draw a parallel line to this line, so this line will intersect this side and this side at these points here. I will take this as D, okay, and this point as E I will take. See, the point D is different, point E is different. Point D lies on this line AB, point E lies on this line AC, correct? So, distinct point. Distinct means different points. Point D is different, point E is different. So, to intersect other two sides in distinct points. That means this line will intersect this side at point E and this line will intersect this side at point D. So, that's the meaning. Okay. Next, continuation. The other two sides are divided in the same ratio. Okay. The theorem is saying when we draw parallel line like this, other two sides are divided in the same ratio. That means the side AB, this and side AC will be divided in the same ratio. That is AD, okay, AD by this DB is equal to this AE divided by next this EC. So according to this theorem, so I have drawn the diagram. Next to this is what theorem saying. When the diagram is like this is what theorem is saying. AD by DB is equal to AE by EC. Now what we have to do? We have to prove this theorem. We have to prove when we have diagram like this. So we have to prove AD by DB is equal to AE by EC. We have to prove this. Now to prove we have to draw some extra lines in the diagram. B and C. Now see, draw the join these points B and E through this line. I'm taking a dotted line. Okay. Next this C and D. Okay, that is done. Next DM, draw a perpendicular line DM perpendicular to AC. AC is what? This AC is right. AC. This is AC. We have to draw a perpendicular line to this AC from D. Okay. Now I will take this as M. See, this is perpendicular to this AC. So that means this here we have 90 degree. Okay. Perpendicular means when we say this and this are perpendicular, the angle at this lines here, it will be 90 degree. Perpendicular means they form 90-degree angle. That's the meaning. Next, now consider this side AB. Okay. Now we have to draw a perpendicular line from E to this AB. So I am drawing a perpendicular line here from here. Okay. So EN. So EN is the perpendicular line and EN is perpendicular to this AB, this one AB. Okay. Since this EN is perpendicular to this AB, the angle here is 90 degree. When I say two lines are perpendicular, the angle at their intersection point, the point where those two lines meet will be 90 degree. Okay. So this is diagram done. Now using this diagram, we have to prove this one. So when we have proved that, that means theorem is it's proved. We have to prove this theorem. Now consider the triangle ADE. Triangle ADE, this one. A, D, then E, this one. ADE. This is a triangle. So area of triangle ED. For area, I will just take AR. So area of triangle ADE. Okay. So we have formula. Area of any triangle is half into base into height. Correct. Now substitute. Half will be as it is into base. So ADE. Correct. This is the triangle we are considering. ADE. So take this as B, base. See, when it is a right triangle, then that time base will be the adjacent. Okay, adjacent will be the base. But when you take any triangle in general, other than except the right triangle, if you take any triangle, based on the situation or the problem, you can take any side as base. So here I will take this AD as the base. AD into base is done. Next height En. Okay. See, this is base, right? When we consider this as a base, height will be perpendicular line. Perpendicular line drawn from this point E. From this point, the perpendicular line is En. En. So this En will become the height. So I will write height as En. Okay. Next I will write this side. Okay. So I will rewrite the diagram once again, because so we have diagram like this, right? I will write small diagram. So like, so A, B, C. See, this is D. Next we join these lines, CD, this line. Next DM. EN. So this was the diagram, because I have already written in the back side of this board. This side, just for reference, I am roughly writing drawing a small diagram. Okay. So we have written the area of ADE. Next, area BDE. Area of triangle BDE. BDE means what? This one, right? BDE. BDE. Like this. This is the triangle. So we have to find area. So according to formula, half into base. Base is what here? DB. I am considering this as the DB, base. So for any triangle, okay, with different sides, we can take any side as the base, depending on the situation or the problem. Now I will take this DB as the base. Okay, then BD, then height will be what? So this is done, then height. So we have considered this triangle, so which is the height? AD, sorry, AD done. Then height will be EN they consider. Hmm. So height will be EN now. You can ask, so we are considering the triangle BD and E. Only this much we are considering, but height I am taking as this one EN. This EN is not the part of this triangle BDE, right? But why I have taken this AN? See, the diagram is this parallel line is there. No, it is not exactly like this. It is somewhat bent like this. I will write this BD separately. BDE. Okay. Okay. This is EN. Okay. So I am taking considering area BDE. This triangle only. But for height I consider this AEN, this one. Why? Why? Because so if you take this BDE, see if this line, if this line is exactly straight like this, that time this will become the height. Okay. But here this line is not exactly in horizontal. It is somewhat bent, correct? It is somewhat bent. That time for height it will be, I will show this side once again. See, for this triangle ED, height is En. Why height is En? It's a perpendicular line. Okay. I have, if you consider this triangle BDE, for height we have to consider perpendicular line, right? So this is not perpendicular line. This is also not perpendicular. It is bent. This is also not perpendicular. But this En is perpendicular. So I have considered BD as the base, correct? For this triangle BDE, I have taken BD as the base. If we extend this BD like this, okay, then N will be the point and N to E will be the perpendicular line. So that time will become the height. Okay, perpendicular straight line should be there to consider it as height. So since DE and this BE and this BD are not perpendicular, they are somewhat bent. So if we extend this BD here, so we will get perpendicular line this EN. So EN will become the height. Okay. So that's why I have taken EN as the height. We have previously seen area of ADE half into AD into EN. Okay. Okay. This thing we have already seen this. Same thing I have written once again. Now this area of ADE can be written in different format also. I will show that. Area of triangle ADE is equal to half into base. So consider triangle ADE base. Previously you have taken AD as the base, correct? AD as the base. This time I am considering AE. This AE as the base. I already said depending on the type of problem, we can take any side as the base. Here I am taking a base as AE. Then height will be what? Yeah. Okay. When I take AE as the base, then perpendicular line drawn from point D, okay, to this AE. So this will become the height. DM will become the height. So DM is the perpendicular line drawn to the side AE. So this perpendicular line will become the height. So DM. So we have got two formulas for area of triangle ADE. This and this. First we considered AD as the base. That time we got height En. Next time we considered AE as the base. We got that time height was the DM. Next, area of triangle DEC. DEC. So according to formula, half into base. First triangle DEC you take. DEC means this DEC. Then this triangle DEC CD. So this triangle I am considering half into base into here base EC. I am considering this as the base. Okay. Next height will be what? Which triangle it is? DEC. So we are considering triangle DEC. So I took this EC as the base. Height is what? Okay, height is what? See, as I already said, height should be perpendicular line. Okay, but if you take triangle DEC, EC is not perpendicular, it is somewhat bent. DE is also not exactly perpendicular, and this also. To get the height, so we have taken EC as the side. When we extend this side like this, when we extend and draw a perpendicular line from D to here, now DM will be the perpendicular line and this DM will become the height. You got it? So now for triangle DEC, height I am taking as DM. Next, I will take the ratio area of ADE by area of BDE. this ratio, area of ADA, we have two formula. Okay, this and this. First I will take this half into AD into EN, that I will write here, half into AD into EN. Okay, half into AD into EN. Now next area BDE, we have this right here, half into dB into En. Now this is equal to, see, half cancels out, En cancels out. What is left? AD by dB. AD by dB. Okay. Next I will just erase this diagram. This diagram is already there in the back side of the board. Okay. So we have taken area of ADE by area of BDE. So this and this done. Next I will take this and this. Area of ADE divided by area of DEC. So area of ADE. This formula I have taken here. Next time I will take this formula, this one. So half into AE into DM. Next area of DEC. This one, this formula. So half into EC into DM. Half into EC into DM. Now we can see half cancels out. DM cancels out. What is left? AE by EC. AE by EC. AE by EC. So we got this. I will take as equation 1. This I will take as equation 2. So look at the diagram. Look at the diagram. See BD, take triangle BDE. BDE, BDE, this triangle and DEC triangle. DEC, this triangle. See, this triangle and okay, BDE triangle, BDE, this triangle and DEC, DEC, this triangle. So we have the same base DE. So D is the common base. See, for triangle BDE, we have common side base DE. If it be for BD also we have side DE, and for triangle DEC also we have side DE. So I already said if you try in a triangle we can take any side as the base depending on the problem and the situation. So here the two triangles BDE and DC. Okay, DEC and this line. Okay, so this triangle and this triangle have this common base. They have common line, and this triangle lies between the same parallels. So this is parallel to this line. Okay, now this and these are parallel lines. Okay, okay, now remember, when two triangles have same base DE and they lies between the same parallels. So these two triangles are present or lie between parallel lines, same parallel lines. This and this. BDE triangle also lies between this parallel line and this parallel line. DEC triangle also lies between this and this. In between these two parallel lines, we have two triangles, and those two triangles have the same common base DE. So because of this reason, okay, because of this reason, so area, I write here, area of this BDE is equal to area of DEC. Okay, you got it right. Why we got this? Because of this, BDE and DEC lies between same parallels and they have same base. So area of BDE is equal to area of DEC. This is important point you have to remember. Okay. Now we understood area of BDE is equal to area of DEC. Now come to this side. Okay. Here see, consider equation 1. In the previous we have seen area of BDE is equal to area of DEC. So in place of this area of BDE, I will no. In example, you have to write in the next step. To avoid confusion, I will write once again. I will just erase this part. I will first consider this only. Area of ADE, I will write as it is. Whole divided by area of DEC. So I already said area of BDE is equal to area of DEC. So in place of area of DEC, I am going to write area of BDE. In place of this area of DEC, I am going to write area of BDE because both are equal, we have seen. So that is equal to this AE by EC. I will call it as equation 3. Now consider equation 1 and 3. See this left sides, this and this. This and this both are same. Area of ADE, here also area of ADE. Area of BDE, here also area of BDE. This and this are same. Okay. When this is equal to this, so this is equal to this and this is equal to this. When this and this are same, so obviously it is certain, definitely this and this should be equal. That means this AD by DB is equal to AE by AC. So I will write from 1 and 3, this equation 1 and 3, we can write AD by DB is equal to this AE by EC. Okay, so in the beginning only I said according to this theorem, this is a diagram, we have to prove this. Okay, so we have proved it. Okay, proved. So done, we are done with this problem. Thank you. Click on subscribe, and anything if you want to say related to my teaching and this concept, you please mention in the comment. I will follow that comments. Okay, thank you.